leg is a bit unhappy, so I have walking problem, so I may sit in the middle. I'm Mohsen Jafari, coming from Rutgers University, New Jersey. And this talk is about basically 2 new projects that we have. So I'm going to go through some of the ideas in the projects and tell you what we are planning to do, what we have done so far. We have a center called Center for Advanced Infrastructure and Transportation, CATE, which has been there from 1999. We have been hosting UTCs all over, like last 20 years. And UTC stands for University Transportation Center. Now we have another new UTC started a year ago, focusing on infrastructure. And my part in this UTC major project is looking at the readiness of the infrastructure for the next phase of the transformation on roadways, smart roadways, and more importantly, connected vehicles. And I don't want to rush into autonomous vehicles because we still have a long way to go. So let's start with connected vehicles, which is the base and foundation for the transformation. Now, New Jersey, being the second richest state in the country, has been quite quiet in terms of adopting some of these new technologies in autonomous. We don't have a testing ground for autonomous vehicles, whereas if you look at some other states, they are working on it. Google is running and Tesla is running their cars in these states. Unfortunately, we don't have it. But with our new governor, there is a big push in terms of the clean energy for the cars as well as smarter roadways. And as part of it, we got the funding, the first phase of the funding, to put an innovation hub, which is going to focus mostly on the mobility and everything that goes around the mobility. And so what I'm going to do is basically my talk is going to go around this innovation hub and what is it that we are doing and where we are heading with it. So the focus is again ECA, electric. Of course, that's the foundation, because honestly, without this, connected autonomous vehicles won't work. There are some estimations from Department of Energy that if you move to this era without actually adopting this, you are going to increase a lot. You're going to create much problem in terms of pollution. And if you just keep on using combustion engine, because the expectation is that with this, especially with the autonomous, miles traveled is going to increase a lot. And that is going to create bigger problems. So for us at the center and in New Jersey, New York area, and even California, the idea is to put all these 3 together. So for us, it's really come together. So speaking about our overall projects, which comes from 2 different sources, one is from the federal, one is from the state, the idea is to look into this foundation for the connected vehicles, the connectedness between the vehicles, between the roadways, and even buildings in the future. We like to connect all this. And now, we don't want to get into the vehicles because we know there are lots of work there, the technology is there, and there's no point for us to do. But infrastructure-based technologies and connectedness is missing. And our focus is more on the infrastructure-based connectedness, how to create connectedness through the infrastructure. And of course, when you look at it, you have basically the physical layer. And again, we are assuming that the technologies are there. What you need to do is just go buy the technology, and that's what we are planning to do. And then comes the communication, 5G and all of it. And again, it is there. So we are not going to do much of it, except that we are going to acquire it. We have the funding to basically put in place for the testbed. Our focus is going to be more on the application. So the way we look at it is that we like to create this innovation hub with funding, major funding from the state and federal, where we are going to take this is actually, if you have been to New Jersey, it's a beautiful state, by the way. It's a garden state. It's all a forest. Most of the factories are gone, and it's much more clean. It's one of the cleanest states in the country, actually. So we are taking a part of a city in New Brunswick, which is close to Rutgers, and that's going to be our test bed. So that's going to be instrumented, and then all the data is going to come to a data center at Rutgers, where we are going to host all this data in the cloud. But then that's going to be the base for the companies and all the rest to use the data to build applications. And this is where, as a university, together with the startups and companies, we are going to be working on the application. So this part is given. It is out there, and actually there's a company working with us. This part is a given. There's no point to spend time on that. It's already out there. So it's really this part. So all these applications from the environment, from mobility, from safety, and all the support applications, really the foundation of what we are trying to do. And this is, so when you look at the types of applications, the first thing you have to comes to your mind is the type of architecture for these applications. And one of the things I want to, in the small, short amount of time, have is to tell you that the infrastructure in terms of IT infrastructure that is already there does not support. You have to move it forward, new front. If you look at the application from purely application side, we are looking at the data. Definitely one of the main applications that everybody wants to do, and honestly we don't have many of them in US, is adaptive signal control. It's a major thing. Most of our traffic signals in US are, for the lack of any better term, it's a dumb signals. They don't do anything smart. They're fixed controls and nothing changes, and depending on whatever conditions happen. Another one is all the EV charging, because when you're doing EV charging, again, depending on what type of charging you have, depending on where the location of the charging and how long you want to wait, you have to really have some architecture in place. So in terms of connectedness, you actually do that. So taking ideas and implementing in this place, which is a very busy area, by the way, close to university. There are many businesses, banks, major healthcare center there, part of Rutgers, one of the largest in the country, plus Rutgers itself, which is about 67,000 students. So you can imagine it's a very busy work on. And if we can demonstrate that it really connected this work, I think we have done something really good. And basically we have near-term elements in here in terms of what that we are going to do. Of application companies to testing and so on. So details. We talked about the system architecture. So if you look at the current system architecture, and I'm talking about US specifically, the ITSI architecture is already there, but it is a one-way street. Basically, you, as a driver, you get all this information on the boards and all this, but you know, that's information, and that's it. You may decide to use it, or you may just ignore it. That's not the way connected system works. The connected system has to be a closed loop system. There has to be exchange of information. And then you have to use this information for the betterment of the whole system. So the current system, both in Europe and US, does not support it. We have all these different types of stakeholders in the system. There are some connectivity between them, but really is not connected. Okay, it's a one-way street. And you want to move on to the next level, where we call it cooperative ITS. This is where it supports the connected. Again, it's not there yet, but at least it's a step forward. And in here, when you look at it, there are some European or international model, and there is a US model, where it tries to support this connectedness in some way. And there are different. You have the roadside units, then you have the vehicle-based units, and basically you try to connect all this and create this. But again, it's not just the data that goes between them, it's an application that you have to make sure that application. So in this slide, what you see is all the existing platforms in terms of ITS, including cooperative ITS, how they compare and what type of overlapping they have. And I'm not going to, it is in our paper, and I'm not going to details of it. But if you take the one that is being used, or at least this is being encouraged in US, that's the better word, this platform where it looks at the different types of applications, again, environmental, mobility, safety, and support, and tries to define different sub-applications within each category that you can actually develop. So given an application in this, queue warning is something very important. It's really an application that tries to connect vehicles together in terms of how they're going to queue up if they are going to intersection or wherever else, and how they can actually use this information to make the queues more efficient. So, and this is the existing architecture. No, but if you take this architecture and actually apply it to a specific project, then you have to build your own logic for it. And that logic depends on lots of details in terms of what type of data you have, what type of instruments you have, what type of vehicles. One of the challenges that you're going to have in future, at least for the next 15, 20 years, is that you are going to have mixed technology vehicles on the roadways. For the lack of any better terms, you have dumb vehicles like my car, which has none of these smart things. And then you have Teslas and others that are level 4, level 3, and level 5 maybe in 10 years. So how you're going to connect all this thing, that's a really major issue that we have to really look into. And this in-vehicle signage application is something very fancy and very nice. Again, there is an architecture for it, how it has to be done. But again, you have to understand that you have this mixed technologies and how you're going to implement it within this mixed technologies, and make sure that a level 0 car is connecting to level 4 car, and together they're connecting to the infrastructure and they actually work on it. It's a huge challenge that we need to really think about. So I'm not going to go through these details. So what I'm going to do is, so as part of this project, we are almost done with phase 1 or rather phase 0 for both federal and state. Now we are writing the proposal to actually build an innovation hub, hoping that, and it will be there soon. You're more than welcome. We'll share our information, collect data. So this is the corridor. What the feds wanted us to do is actually build a simulation model with real data and show that if you actually do connected in a simulation world, you are doing what is the benefit of it? Because it's speaking of cost and benefit, do we really get something good for it? So what we said, okay, built a very detailed VSIM model with all the logic that goes with the current system, which is totally not connected. Oh, okay. I hope it runs. It doesn't, huh? Wow. Okay. Can you go back, maybe? Because it's really real network. We tested this. It's that roadway. I mean, it took us a long time to collect the data. It's the city. Give us so important. Well, let's see. Can you go to?
You come out of the presentation mode. It worked. It worked in the presentation.
Can you do it one more time? Oh. Can you come out of the presentation? I really want them to see it. How much time do I have?
5 minutes.
Okay. So it's not that bad. So so just as okay, maybe you can run it here.
Yeah. Usually it runs that.
Oh, it was running when we did it together.
I think the problem might be the
Oh boy.
Yeah. Maybe we
After the recording.
After the recording.
Yeah, at the end.
Okay.
Show it right now, or?
Yeah, we can see it.
So in the other version, on the connected version, we basically we talked to the stakeholders and to the company that is going to put the instruments and said, okay, given these instruments, what type of logic, what type of connectedness we are going to have, what type of information we are going to bring to the so can you run it now?
Let's run it at the end of the presentation.
Okay, no problem. So sure. So we said, so let's go to this. So this is the real one, and it's actually a very busy area. And this is, by the way, quite a large area. Can you go to the next slide? And then for the connected one, again, talking to the company who's going to be actually working on it, we said, okay, if we take that logic and put it in our simulation and using the same real data, what type of benefits we are going to get from it, assuming that the cars talk to each other, cars talk to the infrastructure, and do all the queue warning and all the different applications. So we put a simple version of those applications in the simulation run. So let's go to the next slide. Well, this runs.
This one runs. There we go.
This is the connected one, by the way. This is the connected one, and this is the vSIM simulation. And I'm sure many of you know vSIM simulation is good platform for doing, doing the traffic simulation. And it really works. These cars talk to each other. They do cue warning with each other. They do acceleration, deceleration together. They try to come to a traffic light when you're getting close to it, and there are so many cars in there. So, okay, why don't you slow down, and so on and so forth. So it's a quite detailed simulation model. I know it's not real, but it's a simulation model because in real there are some factors that you have to consider. How long it takes you to pass the traffic lights. Some of the ideas you want to have in connected vehicles is doing some sort of platooning, so you can actually take the whole platoon and in a very short amount of time push the platoon away from the traffic light. So these are things that have to be added to. We can go to the next slide. So again, this is all rough at this point. One of the simulations we took adaptive signal control. We have our own economic-based model that we are trying to encourage. We take the laws of economics and bring it to roadways, and we look at the roadway assets, the space that your car is actually taking. To us, it's an asset, and there is a cost for it. In that model, you can actually do adaptive traffic signal control. So if you do that with adaptive signal control in that test area, you are doing about 36% improvement, which is quite a lot. And if you don't do adaptive signal control, you are doing 23%. The adaptive signal control basically uses some sort of interest rate, like the real economy, to regulate the traffic lights according to their traffic flow conditions. But you cannot do it if you don't have connected vehicles, because you need to know when the vehicles come to the intersection, at what time they come. You need to know exactly their queuing time, how long they are staying there, and so on and so forth. So that won't happen without connectedness. But if you have the connectedness and you have all this information together, then you can really start doing some very smart things on the roadway. So with that, do I have any other slide? I think that's my last slide. Okay, so I'm sorry that didn't work very well, but basically if you can go back and show them the real one, because the real one is the way Rutgers is all over the New Brunswick, and the students go from one campus to another campus, and this traffic is really a big problem for students.
Right, thank you very